But let's go ahead and talk about different forms of the equation for a line. So yesterday we talked about slope-intercept form, which is y equals mx plus b. And it's slope-intercept because which part of the equation is the slope? N. So there's the slope. And then which part is the intercept? B. And is that the y-intercept or the x-intercept? That's right. So B is the y-intercept. All right, but we have other forms of a line. Does anybody know or remember what another way to write the equation of a line? Yes, Cece.
Sorry, I forgot what I was going.
Okay, that's okay. Yes, George.
Standard form?
Standard form, yes. And how does
AX plus BX equals C?
that's right. AX plus BY equals C. That's right. So we could have it like this. And in fact, we probably saw some examples of problems already in chapter 2 where the equation was written like this. What is another possible form of a line? We can use this form if we're given the slope of a line and its y-intercept. But what's other information that we could have that would be sufficient information to define a line? How about, let's have everybody turn to page 91 in the textbook. And looking in that green box, Jose, what's another form of a line, the equation of a line that we don't have on this list yet? That's right. So we could have point slope. And so that's if we know the slope of a line and we know one of the points on the line, then we can write the equation of the line. And that is going to be y minus y1 equals m times x minus x1. What do the, hello Lily,
Sorry.
no worries. What do y1 and x1 represent here? How is that different from this y and this x? Everyone is happy to be busily working away today. Which means I'm just going to start calling them. So I'm going to come to you next for your theory, Taylor. What is the difference? Here we have y and y1 and x x1. What is the difference between them? What do they represent?
I can let you know, but I don't remember.
Okay. All right. So we're going to need to phone a friend. All right, Lily, I see your hand up first. What's the difference here between x and y and x1 and y1?
X and y are the first point, and x1 and y1 are the second point that you have.
So that will be when we have 2-point form, we're going to have y minus y1 equals y2 minus y1 over x2 minus x1 times x minus x1. So yes, so when we have, but this is a different situation than this one. Yes, Gio.
I mean, you don't really know x and y, but you know the 2 points, like the point that x1 and y1 are.
That's right. So when we have the equation of a line, we're always going to have the x and the y that represent the fact that this is on the xy coordinate plane, meaning that those could be filled in with any number of points that are on the line. So in other words, this x and y are the same as this x and y. They're the x and y that are the parts of the equation of the line. But the x1 and the y1 are the coordinates of the point that we know. And Lily then here with the x2 and the y2, those are the coordinates of the second point that we know. Okay. So my suggestion, so here we go, here's a little pop quiz. Let's say you're doing a problem in this chapter and they ask you to do the equation of a line, and the information that they give you is a point and they tell you the slope of the line. Which form should you use? Point slope, yes. Let's say they give you 2 points. Which form of the line should you use to write the equation of the line? Yes, Cece.
Okay, well, I don't know if this is right, but normally when they do that, but 2 points, is 2 points the two, wait, oh no, I keep forgetting it's 1 or 2. Is that where like a number here and a number here and a comma and then a number here and a number here? That's what you're talking about, right?
Yes.
I hope so. Okay, good. Then what I do is that I do the m equals y2 minus y1 over x2 minus x1.
Yes.
Or it can be the other way around too, so I don't know what I write that. And then I put the slope in, and then I choose one of the y's and one of the x's, but it'd be the same type, and I plug that in, so one for y and one for x, and then I solve for b, and then I take out the points, so then I just have y plus whatever the slope is times x, and then plus whatever b is.
Yes. I would say a shortcut to doing that. So yes, so you've correctly identified when we've got 2 points, this part of the formula right here, the y2 minus y1 over x2 minus x1, that's just the formula for the slope. And so we can do that, we can find the slope, and then we can use our x1 and our y1 to put it into point slope form. Alternatively, you're correct. You could plug those in to slope intercept form to solve for b.
Is it okay if I do it that way instead?
Yeah.
Okay, thank you.
So it's up to you. There are lots, because a line is a very simple geometric construct, there are a lot of ways to arrive at the correct equation of a line. Especially because a line is comprised of an infinite number of points. So it means there's a lot of ways to get to the equation. All right. Let's go ahead. I'm trying to remember what the equation was that you guys gave me yesterday. I think it was y equals, was it 3x plus 5? Yeah, that's what I was thinking too. All right. So now for our notes on graphing inequalities. So we already talked about how to, if we have this equation, I want to make sure to give myself plenty of room here. So we talked about this yesterday, but Gino, what's the one way that we can graph this equation of the line?
You start at 5 and you go 3 over 1.
That's right. So we start at 5 on the y-axis, and then we go up 3 and over 1, And now we have 2 points. And then we can use our straight edge. And we can draw the line. And so there is y equals 3x plus 5. Start at the y-intercept, use the slope to find the next point, connect the dots. You've got the line. But let's say we had y is greater than or equal to 3x plus 5. And so now we need to graph the inequality. Who can remind us what we did? I'll call on you, Merlin. How do we graph an inequality on the number line?
You just put on the number line and then you do a circle and then you do there.
That's right. So we find the point on the number line, and then we're shading in either left or right, depending on if it's greater than or less than. And how do we know whether the circle is going to be open or closed?
If it's greater than or equal to, or just greater than.
That's right. So we're going to have a really similar situation when we're graphing an inequality in the plane, which is we're going to have to pick a direction to shade. We're either going to need to shade to the left or we're going to need to shade to the right. But it's not always going to be totally clear just based on how the inequality looks. So in order to figure out which side of this line is true, in other words, which side of the line to shade, who can propose a methodology for doing so? Yes, Cece.
Okay, so if it's pointing this way and y is that way, then that means that it's bigger, or y is bigger than 5. So then you look at the line, and then since 0 is lower than 5, you want the spot that also shades in 0, so then you shade in the spot that includes 0. Unless it's a negative number, and then you'd want to do higher than 0. Wait, did I say bigger?
Yeah, so we
I
want
meant the
to...
opposite. Okay, if it's bigger, then you don't want 0. Sorry, I was thinking about the wrong thing. Then you want higher than 0, and then you shade in the part that doesn't have 0 in it.
So so you have the right idea, which is...
Does that not work? I thought it works.
We have the right idea, which is that we want to make sure that we're picking a side where one of the points on that side makes this statement true. And often the point 0, 0 is the easiest to plug in to see whether or not it makes the statement true.
I mean,
So if we plug in 0, 0 here, so we're looking at this point right here, we say 0 is greater than or equal to 0 plus 5, and we ask the question, is that statement true? Is 0 greater than or equal to 5? No. So that means that the other side of this inequality is going to be the side that we shade in, because we have to exclude 0, 0. 0, 0 does not make this equation true, so 0, 0 must be excluded. Really, you could pick any point on the plane to plug in to see if it were true or false. Just the nice thing about 0, 0 is it makes the math incredibly easy, because anything times 0 is 0. So it makes the answer self-evident. All right, so Merlin, returning to your point that if it's greater than or equal to, the circle is solid, and if it is just greater than or just less than, the circle is open. How can we represent that same concept with a line?
You could dash the line.
That's right. So if this were just y is greater than 3x plus 5, we would represent that visually by making this a dotted line. So this is how we graph inequalities in the plane. We start out by graphing the line. We check to see if it should be dotted or solid. And it's dotted or solid with the same logic that the circle on the number line was open or closed. And then we pick a point, and 0, 0 is usually the easiest point to test to see which side of the line is true, and then we shape that side. And voila. Are there any questions about what's up on the board right now? All right, in that case, I will leave you mathematicians